Hey guys, Mr. Riz here to help you out on the last day of the 3.3 section. So what we're going to look at here is just more conceptual stuff, making sure you guys understand kind of the big picture behind the first derivative test. So the first thing is, can you look at a graph and just visualize what the derivative is going to be? And so in this problem here, the first problem we have just a constant line there. Well, if it's a constant line and that line is constantly positive, all we need to do is have a straight flat horizontal tangent, but derivative, and we'd have to put it at some positive value. So something like this, that's a perfectly straight line there, could be our derivative. Okay, next, when we have curves, remember our derivative would cross the zero whenever we have mins or maxes. So we have a min right here, so the graph would cross there. We have a max right here, so the derivative would cross zero there. We have a min and the derivative would cross zero here. Now, in between these intervals, we need to determine whether are we above or below based on whether our graph is going down or up. So the graph is going down at the beginning here, so we're going to start below the x-axis, get to our critical point. And then in between our two critical points, the graph is going up, so we need to be above the x-axis. A little too much, but oh well. Then in between, the graph is going down, so we need to be below the x-axis. And after the last critical point, the graph goes up, so we need to be above the x-axis. And there's our derivative. And something like this last one here. Okay, we do kind of have like a critical number here, but the derivative is not equal to zero. In fact, the derivative would be like almost infinity, right? So the derivative would be way up high. So if we look at this graph here, this graph starts out, everything is going up, going up, going up, going up, and it keeps going up more and more and more. Then it's up a whole lot, and then it's flat. And so the graph starts out it starts out positive, but not too positive. And then it increases its positivity, so it gets up higher. And then it basically reaches a point here where it then switches, and it's very positive to now not so much positive. So the derivative graph would look something like this, where every value is still positive values because the graph is going up the whole time. But at the beginning here, it's not as positive as like over here, where it's way more positive because it's going up quicker. Okay, next, what we're going to do here is just to think about our graph and determining the functions of this one here. Now it says f prime of x is, and it kind of gives us a number line here. So maybe let's convert this to a number line. From negative infinity, drawing over a chord here, from negative infinity to negative 4, so that means negative 4 is a critical number. The derivative is greater than 0, so that means the graph is going up. Then from negative 4 to 6, the derivative is less than 0, so the graph is going down. And then from 6 to infinity, the graph is going up. So you can kind of visualize with this graph, it's probably some quadratic like that, or cubic. Okay, so what we want to do here is determine the derivative, whether the derivative is greater than or less than 0, based off of these informations here. And we're going to take g of x, which means we're going to transform the graph. So if we shift this graph up 5, nothing's going to change with the derivative, right? It's still going to go up, down, up. It's just going to be going up higher or lower. All right, so what is the derivative value at 0? Well, the derivative value here, if the normal function is negative, if we shift it up 5, it's still negative. All right, what if we stretch it out 3 times as much and then we shift it down? Well, the graph is still going to be going up the same. If we stretch it out, it's still going to be going up the same and then down the same. So what's the value right now at negative 4 or negative 5? It's positive, so this would be positive. All right, now negative f of x. What if we flip the graph upside down? Well, if we flip the graph upside down, all these values are going to switch. So at negative 6, it's positive, but if we flip it upside down, that would have to be negative. Same thing here. What about at 0? Well, 0, it's negative. If we flip it upside down, that would be positive. All right, what about f of x minus 10? So that means we're going to shift it over to the right 10. So these numbers will just be 10 higher. So this would be 6, and this would be 16. So what about f or g prime of 0? Well, 0 over here is positive, so that would stay positive. And what about g prime of 8? Now, 8 is in between 6 and 16, so that would be negative. Is there a problem below that? Maybe. Nope. There we go. Not too bad. So just kind of going through this. Okay, next, look at these graphs here. These graphs are the derivative here to identify the critical numbers and identify the open intervals, whether it's increasing, decreasing, and determine whether it's a relative min or relative max or neither. Okay, so what we have here are graphs that we're going to turn into number lines. So our critical number is when the derivative crosses the x-axis. So we'd have a critical number at 2. And let's see, that this is all below the x-axis, so that means the graph would have been negative. And this is all above, and so that'd be positive. And so that means at 2, we could say that the graph goes down, then up. This would be a min. All right, in problem 2 here, we got 2 times where it crosses the x-axis, one at 0 and the other one at 1. The graph is above, then below, then above. So we'd be going up, going down, going up. So we would have, in this problem here, up and down, that 0 would be a max. And then down going up would be a min. So these are all derivatives here we're looking at, trying to evaluate the original function. All right, this derivative, looking at its critical numbers where the derivative equals 0. We have one at -1, one at 0, and one at +1. The graph is above, below, so it's positive, negative, positive, negative. So going up and down, so 1 would be a max. Down then up, 0 would be a min. Up then down, that would be a max. All right, next one here, well, actually, no. We only have a critical number, oh, nope, right here and right here. I knew there was more. All right, so we have critical numbers at, we're just kind of taking that, I'd probably say that's at -3. That looks like at -1, and then at +5. Or no, that's +1. All right, the graph is below, it's above, then below. So it's negative, positive, positive, negative. So that means negative, positive, -3 would be a min. How about 1? It goes positive, then positive. That is a critical number, but that would be neither. It doesn't switch from positive to negative. It's going up, then up. So it's probably something like that. And then positive going up to down, that would be a max. Okay, not too bad. Just a couple more problems here. Last one here. This says a differentiable function has one critical number at x equals 2. Okay, so we got a number line here. It only has one of them at x equals 2. Identify the relative extrema of f if the critical number f prime of 1, okay, so that's a number less than 2, is 2. So the derivative value at 1 is 2. That's a positive number. So the graph would be going up when it gets towards 2, and then f prime of 3 is 6. All right, so 3 is a bigger number than 2, and that's up. And so this graph goes up and then up. That would be neither. Now, if this said like -2, we could say, okay, that would be going down then up. That would be a min, but it doesn't. Or if that one was negative and one was positive, it could be a min or a max, but it would be neither. All right, guys, so this wraps up 3.3. We are going to take a mid-chapter test because if we try to do everything all at once, it becomes really crazy. So we'll start reviewing tomorrow, and we'll have a review video for you guys then. Have a great one. I'll see you then.